Hello everyone, hopefully you can all hear me. I'm Peter Fox. I work with Texas Instruments and we're running a 2-hour session today for looking at IB with TI-nspire. If you've never used a webinar before, you'll see that you can access a chat section. That's the little speech bubble down the bottom, and you can send information to and from myself, Sanjeev, who is also presenting with me, and then we'll be able to answer some of your questions as we go through. We will also be asking you guys some questions, and some of them have a mathematical nature, so make sure you're ready to do a little bit of maths, because you don't want to sit there for 2 hours and miss out on doing maths for that whole time. So, just to introduce myself, as I said, Peter Fox, Texas Instruments, and Sanjeev, are you there?
Yes, I am.
All right, so between the two of us, we hope to get through quite a bit in this session. I can see we've got quite a few people on already. So let's kick off, because there's a lot to get done. We'll start by looking at the specification comparisons between at least 2 of the calculators that are approved for IB, and the specifications on those devices. Then we'll have a look at introducing the family of products with TI-nspire, and then we'll have an overview of what you can do with TI-nspire. What is it in terms of the functionality? What are the different environments and applications, and how do they all work together? Then we'll have a look at some sample activities. Now, the activities that we offer are free, and you can download them from a range of websites. I manage the Australian TI website and put much of the content up there. There's a huge amount of content on the US website, and of course your local websites are also available for sharing resources and downloading things like the operating system. But we'll take a specific look at some of the activities. And also resources. Now, resources are a little bit different than activities. For example, on the Australian website, we're also running video tutorials, so we can show students how to actually use the product, be it to answer an exam-style question, or whether it's just learning how to do something. You'll see those videos are posted on YouTube, so they are also absolutely free. We host them on our website as well, because on our website, the students can go through worksheets to make sure that they understood what we covered in the tutorial. Again, all free. We'll have a quick look at some of the things such as TI Navigator. That's a wireless platform for the calculator. That is one of the most powerful tools. I'm proud to say I was on the development team, as I was also on the development team for TI-nspire. So quite familiar with it, very proud of what we've done with Navigator. I haven't seen a parallel to it anywhere. And TI Innovator is another really powerful tool. That's for STEM. That allows students to do things like control motors, pumps, lights, interact basically with the outside world. If you've used some sort of programmable microprocessor before, that's essentially what it is. It can be connected directly to a student's calculator or to their computer through the nspire software. Then there's TI Rover. That's a robotic vehicle. To give you some idea, it's not just like a normal robot. That is, you can tell it to go forwards and backwards, or you can tell it to draw a function. In fact, one of the activities we have on our website is that students need to use calculus to get Rover to do an automatic park. So it's got a parking spot that it's got to get into, and they have to use calculus to solve that problem. And then Sanjeev will talk about Publish View, which is a great way to create interactive content. Very important at this time, as many regions around the world move to online schooling, so you can share resources with your students. It's very difficult often to and or time consuming to create an electronic document that has a lot of mathematics on it. whereas Inspire and Publish View in particular are specifically set up to send electronic mathematics documents where you can have graphs on them, video, you name it. Very powerful tool. And finally, Sanjeev will go through some sample exam questions on how you might handle them on the calculator, bearing in mind, of course, we understand that exams rather, you need to have the calculator in what we call press to test. That's because it's a particularly powerful tool that can save documents, so IB require it to be set up in press to test. But we can show you how easy it is to get in and out of that. Just a couple of clicks and you're in. All right, so let's have a look at some comparisons. The calculator is often used for IB is the Casio CG50. So we're having a quick comparison with the TI-nspire CX2, specifically the non-CAS, but the CAS has basically the same specifications. The CAS is also approved for IB, but it must have the CAS functionality switched off in an exam, and I can show people how to do that if they're interested. If we're looking at processor speed, the advertised speed of the Casio is 58 megahertz and the Inspire is 396. So it is a particularly fast machine. In terms of memory capacity, the advertised memory for the Casio CG is 16 meg. However, in Australia, they limit it to 4.5. Not sure why they would do that, so it's something you just need to check in your region if it's being limited in any way. And the Inspire, well, there's a combination of 64 meg basically for running the content, but 128 additional megabytes for saving files, which I have never come close to filling up. And I save a lot of stuff. Screen resolution, very similar. If you look at the total number of pixels. And then finally, batteries, and this is one real big convenience as far as I was concerned when I was teaching in the classroom, is that the Inspire comes with rechargeable batteries, which basically means the kids plug it in every couple of weeks, charge it up, and then it's good to go for a couple of weeks. My daughter used hers in high school. My son has taken over using one, and that battery lasted for about 6 years. So that gives you the idea of the sort of saving. Other than landfill, the cost is much, much cheaper just to plug it in and charge it up when you need it. As a teacher, if you want to charge up multiple handhelds at once, you can plug them into something called a docking station and charge the whole class up while they're sitting there doing a test or something, and then they could be charging their calculators. Obviously, they can charge them from their computer or a wall outlet, so it's pretty easy to do. The price comparison I took in Australia, I'm not sure what it is in different regions around the world, but you can see local suppliers in Australia, not that you'd be buying it from here, the Inspire actually worked out cheaper. It's not the case all around the world, but it certainly is here in Australia, where we try and keep the price of the Inspire as competitive as possible. I'm not sure what that converts into in the different currencies, but that gives you an idea. All right, so let's have a look at what we call the Inspire family. So what I'm talking about when I say a family, some people just think of it as a calculator, but it actually has a lot on it and a lot of stuff you can connect to it. And I will actually connect some stuff up to it during this session. It's hard to do in a webinar, much easier to do in person, but current circumstances mean that that's not an option. But we'll show you how you can connect up some basic data logging stuff, for example. The first thing is when students purchase the calculator, they get the family software, that is the Inspire software, which means that anything they do on their calculator, they can save that to their computer. Or, alternatively, the teacher can create some content, save it on their computer, and it's full functioning software. It's not an emulator. A lot of people think it's just an emulator, but it is a full functioning piece of software. Just as you've got Word or Excel on your computer, you can save files and never even transfer them to a calculator if you don't want to. But if you do, you can email those documents to the students and then they can open them up either on their computer or just drag and drop them on the calculator, keep working. When they're done, they can save that, send it back to their teacher. There's even a notes section, which you'll see later on, and that allows the teacher to add comments to student work. So you can essentially use it like a marking tool as well. So the software is an extremely powerful aspect or component of TI-nspire, and it comes with the student calculator. The next part of the TI-nspire family is something that we call a TI navigator. It's a wireless classroom tool. Now, there's a little cap that goes on top of the calculator, as you just saw, the little yellow cap now sitting on there. Obviously, it's a separate part. It doesn't come with the calculator because it's only something that you would generally use in a classroom environment. So the calculator itself is not inherently wireless, otherwise it wouldn't be approved for exams. So it's always a little add-on. And it allows the teacher to see what every single student in the class is doing on their calculator. So you can see if they're on track. I've used it, for example, I've given the students a problem to solve. I want to know how are they solving that problem. And I can get in and see, oh, some kids are using a spreadsheet. Others are just using guess and check. Someone's using a graph. Someone's using, in my case, a bit of algebra. You can see what they're all doing. In fact, if a student has solved the problem in a different or unusual way, you can automatically make that student the presenter and they share their screen with the whole class via the teacher's computer. You can record it if you want to. So the student doesn't even need to leave their desk and they're presenting wirelessly and talking and sharing with the rest of the class. It's a very engaging tool and the students absolutely love it. You can decide whether or not you want the students' names displayed, but I can guarantee you once a kid has their screen up on the actual board, they're pretty excited and they go, oh, that's mine. So even if you left it anonymous, it's irrelevant because the kid's going to yell out, that's mine, that's mine. And they normally write something to you like hello class or something. You can do a poll. So a poll is where you get to ask the students questions. You can decide whether you want to allocate marks to those questions, whether they're of a mathematical nature. You can ask them to contribute a graph. So you could say to the students, I want you to give me the equation to a straight line that passes through the point 2, 3. And you can watch every single graph appearing on a common set of axes as the kids contribute whatever graph that they've decided they'll choose. So we've got a chat space here. I'm going to use the chat space later on to ask everyone a question, and it's just the same. The difference or the amazing part is that every student gets to answer. So you've got kids in your class that, for example, will be worried about putting a hand up to answer a question because they don't know if they're right. You can make it anonymous and every kid gets to contribute, which suddenly means every kid has got buy-in to that answer. There's plenty of research that tells us that that is a very powerful tool to be doing, is engaging every single student, not just the one that you think is probably going to get the question right. You can also use some of the settings. You can access the settings on every single kid's calculator. So that time when you're introducing trigonometry and the kid says, oh, my calculator says sine of 30 is equal to negative 0.68 something, and you're thinking, what have they done? Oh, they've left it in radians instead of degrees, or vice versa. You can actually put the settings that you want and send it out to every single calculator. Or you can put every single calculator into press to test and take it out when they're done. In fact, if you're running let's say a test, which you can do, you can send an entire test to the students. You can lock every single calculator down at the start of the lesson wirelessly, send them the test. They do that on their calculator. You then collect it. The software marks it for you, and then you take the calculators out of press to test, and it will delete everything that the kid did during that lesson. And that way they don't have a copy of it. They can't give it to anyone else. Even if they save it under a different name, it's irrelevant. You can clear it straight out. You can also send them a document this lesson, retrieve it, and then resend every single kid their own document back with a click of a button the next lesson. So they're working on an investigation. You can collect all their work, provide feedback, and then just hit redistribute next lesson. And every kid gets their file back with the teacher comments on it. That's pretty cool. And the last one, as I sort of alluded to, you can ask students to complete an entire test. We've got some on the TI Australian website that are already made up. You can alter them, edit them. It's one of the applications on the software, the teacher software, that you can create a question. You can decide whether the software is going to assess it, or you can leave it so that the student's calculator actually tells them whether they got that question right or wrong. So it's a great way to actually give students a question sheet, a test if you like, without having to print any paper whatsoever. Everything's done electronically. So that was Navigator. The next one is data logging. There's something called a lab cradle that slides on the back of the calculator. If you've got one, you can turn it over and see that there's this funny communication port on the base of the calculator. That's for lab cradle. Also the charging bay and the docking station where you can transfer files using a wired system if you like. And then the CBR, which is a motion sensor. I'm going to use that in today's session because it's quick and easy, and it's an example of one of the activities we have on our website. So you can collect motion from that. With the lab cradle, I think there's something of the order of 45 different sensors that you can connect up to the calculator. Speeds of up to 100,000 bits per samples per second. So you can collect some data pretty quickly. That depends on the probe. There's turbidity, pH, temperature, light, voltage, microphone, you name it. As I said, you can go through the Vernier website and it tells you which sensors are compatible with the actual lab cradle itself. And it's all built in. As soon as you slide that tool on, the calculator automatically detects it. It tells you what probes are connected, and you just click a little green button that says Start Collecting. So you don't have to be an engineer to work out how to use it. Speaking of engineers, the next one I want to discuss is the Innovator. That thing pictured on the screen at the moment. If you've ever used something like Raspberry Pi or something along those lines where you can program a microchip, that's basically what the Innovator is. But it connects to a student calculator or the software, and you can just use BASIC. So in, say, for example, Raspberry Pi, you'd use about 20 lines of code to program the LED to do something. On Innovator, you can do all that with one line. So we've made it easier for kids to access. It's done in BASIC, not C++. So it's really easy for kids to get started. We've used this with kids as young as 12 and 13 years of age. It's also a great way to get them into programming if you want to. But there's activities you can do all the way up into the senior levels. So that's the Innovator. The next one is what we call TI Rover, or its full title is TI Innovator Rover, because underneath its belly is the TI Innovator. It's like an add-on to the Innovator, but it's often thought of as an entity in its own right. You can see that it's just got a couple of wheels. The calculator slides in on the top, and you can tell it to go forward, backwards, left, right. You can see it's got a motion detector on the front, so it can detect how close it is to an object. You can plug in up to 6 other sensors, inputs and outputs, whilst the rover is going. It has a light sensor underneath, colour sensing. A lot of things you can do with that. As I said, we're doing some calculus with the students where they've got to program it to get out of a parking bay. But you can also do really simple experiments, problem solving. A colleague of mine over in Western Australia, he gets it to play fetch. So the first task the kids have to complete is Rover has to drive out, go and fetch a ball and bring it back, which is really only using forward, left, right sort of commands, but it's pretty clever. And then the next task he gives them is an extension of that, where he has a whole lot of objects scattered around the table and tells the students, right, you've got all the coding that you need to know and all the logic, so go ahead and tell it to collect all the items off the desk and bring them back. And it's a time challenge, so the kids have to do it efficiently. That's pretty clever. So it gives you an idea of what's in the nspire family, not just a calculator. It was like 5 or 6 items that pair up with it. So very quickly, we'll go through an overview before we start working on some questions and some investigations. The calculator application. So TI-nspire works off a base of 6 applications. The extra one, the 7th one, is the Vernier data quest on the very end, which we'll have a look at later. But the main 6 applications that students will work in are the ones that we can see, plus that extra green one on the end, 7th. In the calculator application, that contains a history of all calculations. They're static. When you're finished, they're done. But that's not the only environment where we can do calculations. You'll see that there's a 2-dimensional set of templates so that they can follow natural mathematical notation. We don't need any special syntax to remember how to do the integral of something or the numerical derivative because it's all set up. It says dy dx, and you put your function in and you tell it where you want to find the gradient of that function. That's pretty cool. But one of the more powerful sections, and this is true on all applications, is what I'd call an intuitive menu structure. That is, we don't need to press lots of buttons. It's one button, menu, and then just follow along until you find the operation or the thing that you want to access, whether it be to find the factors of a number or whether you want to find the numerical derivative. It's all in the one menu and it's all written in natural language. So we'll have a look at the calculator application shortly. The next one is the graph application. They're dynamic, interactive. You can do relational graphing, for example. I'll do one in just a moment to give you an idea. And 2D or 3D. So it does 3D graphing. You can get an object, a function, and rotate it around the x-axis or rotate it around the y-axis. That's up to you. So just to give you a quick idea and to get away from the PowerPoint for a moment, let me just bring up, I'll just put my phone down. Let my computer catch up to where it's on. I'll create a new document and we'll choose a graph. So this is our graph application, and I'm just going to do a really simple one, x squared. And if you want to dilate it, then you can just grab it and move it. Mine's being a bit recalcitrant at the moment. The other thing we can do, just I mentioned that it had relational graphing. Oops. Sorry about the lag, folks. Let me just go into the student software. Go. So, relational, I'll do that quadratic again. You can see it just updates the equation automatically. You can grab it and translate it. But let's just get rid of that one. If you want to type in the equation to a circle, let's try x squared plus 4x plus y squared, minus 6y equals, I'm going to say 25. We'll see if that works. Look at that. So it doesn't have to be in any particular format. There are templates which you can use when you're doing relational graphing. You can put down equation templates such as circle, ellipse, hyperbola, conic, and see the different formats for them, but you don't have to stick with those. You can put it in whatever format you like. Now, if you had to, let's say, work out the, I don't know, radius of that circle, You could do it algebraically, obviously, and factorize it, not on the non-CAS, but you can do that by hand. That's still allowed. But you can also analyze the graph. Because this is a conic section, you can see we can get the radius of it. So it says that the radius of our circle is 6.164 whatever, and of course it automatically puts that line in so you can just drag it around. If you want to find out where it crosses the x-axis, you can do those things too. Under Analyze Graph, you can see that we've got things like point of intersection, zeros, minimums, maximums, analyze conics if you want to look at asymptotes and those sorts of things, center, foci, a whole lot. So that's our graphing application. As I said, 2D graphing, pretty easy. 3D graphing, I've got a couple of samples I can show you later, see how we go for time. Next application I'll talk about is geometry. So there's shape tools. You can do Euclidean style constructions where you get perpendicular lines and so on, and you can create interactive documents. Some of the things that we use for calculus, which I'll show you in a moment, are created in the geometry environment, and then you can use it to do calculus. Let me just give you a quick example. Again, I'll just jump back to the student software. I'll go into the home screen where we can see all the apps down the bottom. Let's give my computer a chance to catch up. There it is. And I'll add a geometry application. So I'm building up a document at the moment. Just a document of bits and pieces, but it's still a document nevertheless. And I'll put a triangle in there. Now, on the software, it's easy to do a right mouse click and look at all the things that are relevant to my current object. On the handheld, you do control menu. That's the same as a right mouse click. And let's measure the area. You can see it's measured the area of our triangle. And obviously, if I move my triangle around, it will update. But here's things I like to do with it. I'm going to right click on that measurement. And I'm going to change the attributes. There's a little padlock, and I'll go down and lock it. So now my area is constant. So what I want to know is, can I change that triangle now? So is my triangle unique? Now I'll put that out in the chat. And I'll wait just a moment and people can send in their answers and tell me, is that triangle unique? In other words, are all three vertices stuck where they are? Is every other triangle with an area of 72.5 going to look like that one? Or bar a rotation here and there? Or a reflection? Or can I change its shape? So by all means, send your answer in there. Now, if I was doing this on Navigator, that question would have appeared up on every kid's calculator, and then they have to respond to it with an answer before they're able to proceed and do anything else. So let's show you what it looks like. I've locked the area, and I can change the shape. Probably not a surprise to anyone, given the answers, but I can't move it up and down. I wonder how that point's moving. So let's just do a trace, a geometry trace of that vertex. We can see that the triangle, the apex of the triangle, moves parallel to the base. So what's staying the same and what's changing? Well, two of the sides are changing. The base is staying constant and the altitude is staying constant, so the height. The height and base of the triangle are the same for all of those triangles that fall on that line. So there's some nice geometry you can teach the kids, and you saw how long that took to create, all of a couple of seconds. And then you can save that and send it to students and say, tell me what you can find out about this triangle. Maybe you need to give them a few more clues along the way. So that's our geometry application. You'll see more of that shortly as we go into some slightly harder questions. Spreadsheet. The spreadsheet's pretty cool and easy. In fact, you can copy data straight out of an Excel spreadsheet and paste it. Even most of the formulas paste straight across. And obviously there's fill and autofill. Let me do a quick demonstration on what that looks like. Then use a keyboard shortcut here, Control-I, to insert spreadsheet. And whilst I'm talking about keyboard shortcuts, we've got a couple of videos online which run through these things because students are already familiar with them all. Control-C for copy, Control-V for paste, Control-Z for undo, Control-Y for redo, and so on. So all of those sorts of things are in there. So let's do a really basic one. Let's imagine we started typing in the numbers 1, 2, and we want to know what comes next. I can just hold down the Shift key and drag, same as I would on a spreadsheet, because it's a spreadsheet. Or I could type in here, equals A1 plus 1. And I can either drag it down, same as I was before, or I can use this option, menu, data, and fill. And of course, if I change the first term, it will update all the other terms, as it should. You can enter an entire formula here. You can give this data a name. So I'll call this data, not very exciting. And I could say equals data squared. So you can make cells that correspond to other or talk to other cells. And of course, everything will update when you change it. You can then go back, because all of the applications are linked. If I went and put a calculator application in here, and I type data, and data squared, and sum data, all of those things work, because all the applications are linked. So it's picking up that in the spreadsheet, you put those numbers, and I can use them here. In the algebraic version, you can do calculus in there. So you could put sine x in the first cell, sine squared in the next one, sine cubed, and just fill down, and then in the next column, get it to differentiate each one. All right, that's it for spreadsheets. There's a lot more in them, but we're limited to time. The data and statistics application. I know it's not particularly pleasant, but I've been monitoring the data for the coronavirus in Australia. Let me just see if I can bring that up. Let me get rid of that one. So that's it on a graph application, but equally, I could insert a data and statistics one, and then I just click down the bottom and say, I want to have a look at the day and the number of cases. And you can see in Australia's case, we're heading towards a logistics curve, we hope, with a point of inflection somewhere around about the 3,500, and we can obviously do some calculations on that. Let's see if it's happy to do a logistics regression. It's a bit slow. I've got too many things running on that one. But that's the data and statistics application, and it automatically links to all the others and does live updates. Sanjeev might show you some of those if we get a chance. The notes application. This one's really cool. You can combine text with calculations. Let me do a demonstration on that one. I might just close up the CAS one because I'm going to do some data logging with you guys in a minute. So I'm going to close that one. Flattening the curve. You keep checking, do I want to save it in my files? So let me go into the notes application on the non-CAS. So notes, and I can type in instructions. I can also put in maths. see there, it's automatically updating. And if I change my rule, changes my output. This is a really powerful spot for students to be able to test things, explore. All right, let's go back into here. And the last one is our brilliant data questions. It says there up to 100,000 samples. There's 75 different sensors there, more than 75 now, and up to 100,000 samples per second. And it's really easy to use. All right, so I thought we'd do a few activities. That means it's time for you guys to do some maths. You've been listening to me for just over half an hour. Now, the other thing I might do, sorry, Sandeep, I can hear your microphone in the background. Are you able to just mute your microphone for now? All right, so let's have a look at this one. This one is a lovely maths problem. I'll show you where it is on the TI Australia website. As I said, it's one of these ones you can download for free. So you can see there's a student worksheet, there's teacher notes, and a TI-nspire file. So we've given you all the answers, the questions, and so on, so you can download them. The calculator needs to be on at least 4.4 or higher to access this. If they're getting a CX2, obviously that's 4.5. Now, even though this one's done in Victoria, and the actual activity involves some algebra and calculus, they don't need the CAS to do the algebra and calculus. They can do that by hand. You can still do this activity as we will. So, to get the file, I can just click on that one there, and you can see down the bottom left-hand corner of my screen, it says it's opening. Let me just check to see. I might have already opened it on my computer. No, I haven't, so that's all right. Let's just clear off that one. And I'll go back in here. Oh, it's going to open the CAS one. I should have told it to open the non-CAS. Never mind. Sorry about that, folks. Just give it a moment. Because my computer always uses the CAS, or almost always uses the CAS, it's going to open up the CAS version. So here's our question. This is a math question. Actually, let me just go back to that. File. I should be able to see it on recent. I can. Look at this. Paper folding, calculus. There it is. So here's our little math problem. We have an A4 piece of paper, which means it is 21 centimetres high, 30 centimetres long, near enough, and we fold it as you can see there. Now this diagram is done in the geometry application, so you can see it's a very flexible space to be doing stuff. And it's measuring the height and area. What we want to do is maximise the area of that little yellow triangle there. So we can see at the moment it has an area of 37 centimetres. If I drag this down a little bit, got 42, and now it's going back down again. So the maximum seems to be about 42 point something, and the height's around about 7 centimetres when that maximum occurs, approximately. And you think that's all it's been doing at the moment, but in actual fact, in the background, it was capturing some data. So, as a teacher, we can also have this little thing here that allows us to step through and says, well, let's let the height be X and the base equal B. So I'm revealing some clues as we go along. And the section at the top is 21 minus X because our page is 21 centimetres wide. Now, hopefully you didn't see the equation there, but see if you can work out the formula for the area of that triangle. You don't have to do any calculus yet. There's a bit of a clue here. This length here you should be able to calculate. That's the top of that fold there. So I'll give you a minute. See if you can work out a formula for the area of the yellow triangle. If you've got it, by all means send it into the chat. And whilst you're doing that, I'll just set up that little graph again. Now, I'm hoping someone will type in something in the chat space there. No pressure. I'm going to show you what happens, just in case no one does. We haven't got all day. I might start you off. So let's suppose a student answers what I've written in the little notes application and they submit it in the chat. So, if you were doing, say, remote learning for your students, and a student sent this in, I'm going to copy that. You can see it's written in text, and I'll change my graph back to a function, and I'll just paste Control V, and look at how it pastes it. It actually reads that text and converts it into mathematical notation. I think that's pretty cool. But the best bit is, it was collecting data as I was moving it before. So I want to see, is my equation correct? And at the moment, I can see the equation's not correct. So now it's up to the students to figure out, well, what's wrong? What's wrong about my equation? So I wonder if it was supposed to be 2x. Left out the 2. But now I can see that the equation that I came up with, the algebra that I did, models the actual function or the data as it was being collected. So it's a true representation of that geometric environment that we've created. So that's the geometry application. It's talking to the data application or the graph application, and I put some instructions in this notes page to tell the students what to do. And again, you can just send that out to students as it is now. They can actually download the nspire software at the moment for free, get a 3-month version of it. In fact, it's 6 months, that's all I lie, a 6-month version of that, and you could do that activity with them now, even though they're not necessarily at school. I think that's pretty cool. All right, so that's that one. That might be one that you would do with calculus, but you've made use of the geometry application in the meantime. All right, here's a good one. This one's called Calculator Blackjack. Now, again, I can just click on here. Now, I'll give everyone that's attending here a copy of this slide set, so that way you'll have links to where these activities are so that you can see them in their entirety. So this one here, the problem is I want to play cards, but I'm not playing cards, I'm playing them electronically. So in normal blackjack, you would keep on drawing cards until your total score, that is the sum of all of the values on the cards, exceeds 21. If it exceeds 21, you're bust. Well, I could do the same and simulate that, but this one's more fun. So if you've got a calculator in front of you now, here's what I want you to do. This is this time I think I'm safe. I think I'll get 2 goes out of this before I go bust. So I could just go back up here and generate another random number like that and then add them and go that one plus that one. But you saw before, you can do it a lot quicker. So I wanted to get my total, and I think I might even get a 3rd go out of this, plus random number. Nope, I bust. So that turn took me 3 goes, and then I was bust. I'll do one more so you get the general idea. This time I'm just going to arrow up. I'm not even going to use the menus. Oh, it's not looking good. I think I'm going to be bust after 2 goes. So I'll plus, and notice it brings up answer. As soon as I type in plus, it assumes you're adding it to the previous value. Plus random. Oops, not that one. I went up too far. I could have done Control Z, by the way. Ooh, I get to live another go. That was a really small random number. So we'll do that thing, plus another random number. Okay, so 3 goes again. So the first time I went bust after 2 goes. The second time I went bust after 3 goes. The third time I went bust after 3 goes. I want people to either trial it themselves, but I definitely want you to guess, on average, how many random numbers does it take before the total exceeds 1? So I've had 2, 3, and 3. You could be presumptuous and take an average of that, which is what, 8 divided by 3, 2.67. Or you could try a few more. So send some answers in chat space. On average, how many random numbers will I generate each time I go bust? I'm going to keep on doing a couple while you guys figure it out. I'm figuring out I just got 4. That's unlikely, but I got 4. Alrighty. What's this got to do with IB? Let me show you. This particular program, or this particular file, comes with a program that I wrote called Blackjack. It says, well, let's not just do one game, let's take a sample. Let's try a sample of 25. So I'm going to play 25 games, the computer's going to simulate it. And after taking 25 games, it says the average was 2.72. So on average, about 2.7 turns before you go bust. So I'm going to insert a data and statistics application because it stores the files for me. So we can see the first column is how many times it came up with a 2, how many times it came up with a 3, and how many times it came up with a 4. And we actually had one game that came up with a 5. It took 5 goes to go bust. So what? Another feature of this software that the kids use. Oh, someone wants to know, is that heading towards Euler's number? That's a strange suggestion. Okay, let's try. Variable, blackjack, average, let me say 25 in my sample. This time says, how many samples would you like to do? I'd like to do 100. So it's playing 100 lots of 25 games. You can see it's already done. So we've got an average of 2.72 and a standard deviation of 0.165. We can also have a look to see what that distribution looks like. Here it is, a data and statistics application, and there's our sampling distribution. It's a distribution of all of our sample means. That's kind of cool. And for those of you that understand, it's probably normally distributed. So I'm going to go back to the previous page, and you'll see in my variable list, the first one is just a number. This little icon indicates that that variable is a program, and the last one indicates it's a list. So if I bring up samples, that's the average of each of those 100 samples. 2.72 was the average of the first 25 games. 3.08 was the average of the next 25 games, and so on. So I'm going to call that data 25, because it's data consisting of 25, or sample sizes of 25. I'm going to play the game again. Blackjack. I'm going to have a sample size of 100. That is, I'm going to play 100 games, and I'm going to do that 100 times. So we can see the average ticking along there, and it's done. 2.718. That looks almost exactly the same as what it was before. It seems that there's no point. It seems that the average, regardless of how many I have in my sample, is about the same each time. But isn't that a concept we want the kids to get? But one number that is quite different is the standard deviation. So let's go back. They seem very bunched up. I could spread them out, but this is the sampling distribution when I play 100 games. That is the average of each 100 games. That's the distribution. So I'm going to add another X variable. Remember the ones that we did for 25 games? It seems that my distribution is more spread out when I take an average over 25 games compared to if I average over 100 games. There's less variation in my mean in a large sample. Now, I'll go back. Let's have a look at the standard deviation of this setup here. Copy. Let's go down here and paste it. Actually, before I do that, Control Z, let's do divided by. Paste it. Paste. Let's get this value. Copy. Paste. Gee, that's unusual, isn't it? I had a sample size 4 times bigger, and the standard deviation was only half the size. In other words, when I had 25 games and then changed to 100 games, I changed the standard deviation of the sample, sampling distribution rather, by a factor of 2. 4 times as many objects in my sample corresponds to the square root of 4, sigma on root n. So it's a lovely way of introducing that sort of thing. And someone said, is it E? Is it Euler's number? Yes, the average is actually Euler's number. So it's kind of a cool problem to give students. All right, so that one's called blackjack. Well, calculated blackjack. Next one, and probably my last one before I hand over to Sanjeev, is one on number and algebra, Fibonacci sequence. Now, we can just do the Fibonacci sequence, but if you really want to push it along, and I'm interested to know if people have ever done it in the chat, has anyone ever done the, well, this is sometimes called the golden ratio, has everyone done the silver ratio? or the bronze ratio, because they're actually just as cool. In fact, the Fibonacci spiral that we see there, and it's often applied to nature, is not actually the golden ratio that applies very often. It's more likely to be the silver ratio or even the bronze ratio that gives that spiral. We can see that one there, but that one doesn't actually model nature all that well. It's the bronze and silver one that actually give a better model. Anyway, enough of that. So here's another link to the activity on the Australian website, but I'll show the other website shortly. So you can see you can just download the question sheet. Now in this one here, let's just have a look at the question sheet. You'll notice there's no Inspire file that goes along with it. But you can download this PDF and send it to students. It includes all the instructions the students need to do the activity and the separate one. So if you're trying to prepare classes for students remotely, all the instructions in here. In fact, for a lot of these, we also have video tutorials on them as well on how to get started. We don't reveal the answers, but you can get students to watch the tutorial, which shows them how to do the calculations on the platform. Let me go back to the student software. I'll get rid of my blackjack file. Don't need it. I'll create a new document and a spreadsheet. And I'll call this Fib. Now this will test to see if people were listening earlier on. If I put one in there and one in there, if I want to put a formula in for Fibonacci sequence, how would I do it? Hopefully you recall, same as a spreadsheet, equals A1 plus A2. So it's the sum of the previous two terms. And then I don't have to keep typing the formula in. I can just arrow back up. This time I'm just going to click and hold the mouse button, and that actually selects it. And then you can arrow down. So there's so many different ways you can achieve these results. Fill down. 30 terms is enough. Now, if I was looking for, say, a ratio, I could say in here equals, let me think, A2, press tab, oops, A1, some use a menu, data, fill. Oops, going sideways, I want to go down, there we go. That's nice, isn't it? They're fractions, not particularly useful. Because we're looking for a ratio, we need a numerical sort of an answer. So we can put things in like approximately if we wanted to. We could say approximate value and then fill down. You can see it's tending towards some value, 1.618. And before I said that these things are automatically linked. So what's this? I'll insert a calculator page. Actually, yeah, I'll insert a calculator page and I'll try a graph one. Not a graph, a notes application. So I can put in here, because I called it Fib, so that's the fourth term in my Fibonacci sequence. But I can also do my calculations here and write Fib, say 20 over Fib 21. And if I do Control and Enter, I'll get the approximate value for it. I've got that upside down. I should have done 21 over 20. That's interesting though, isn't it? What's this? 1 plus that. I wonder what that is. Let's try this. Fib 21 over fib 20. Oops. It seems that if I do 1 plus term 20 over 21, I get the same as the answer of term 21 over 20. Something about that golden ratio. And that's some of the stuff that the students explore. Are there any other patterns you can find with this particular thing? So let's try what happens if I square it. And subtract 1. Oops. Seems I come back to the same value. Well, we haven't proven it or anything, but the numbers certainly appear very similar. There's lots of other patterns you can do with the Fibonacci sequence. Let me see if I can remember another one. Let's try. I'm going to try and see if it'll work here. Here's my templates. I haven't tried this on the non-CAS. I know there's sneaky ways to do it on the CAS. Let's try this. Because the students need to know summation notation. Let's go from n equals 1 to 5. That seems to work. So it gives me 40. Let's have a look at this. Not that one. Let's try and remember what that pattern is. So if I sum up the first n squared Fibonacci numbers, I did it for 5, I get 40. If I multiply the 5th and 6th Fibonacci term, I get 40. Let me show you how the notes application works for this sort of stuff. Notes. I'll put a math box in, insert math box. And I'm going to go back here and I'm going to copy, just saves me typing, paste, done. Not very exciting yet. But this is me making a learning document or a document for students to explore. So in here, I'm going to add in a slider. I'm going to call my slider B, because I can. And we'll go from 1 to, I think we had 30 terms. That'll do. So now I can just click on here and I get B. Now if I click in here and do B, that was 1 squared plus 1 squared plus 2 squared plus 3 squared plus 5 squared. And then, what if I do this? Fib B times fib B plus 1. Kind of cool, isn't it? So if you get the nth Fibonacci term and sum all of them up, square them and sum them all up, it equals the product of the next two. That's the sort of stuff we put in our worksheets. So they're not just, let's drill more of the left-hand side and the right-hand side. There it is as question 3 in this worksheet. And then students can also study and explore that diagram and study and explore the ratio. And there's another little quirk with the Fibonacci sequence. Phi to the power of 1 plus phi squared equals phi cubed. Does that work for any other powers? Calculate the reciprocal of phi. What does that tell you? What about if you square phi? What if you have high phi? No, that's just a silly math joke. All right, so that's the Fibonacci sequence. Now, I said I'd go through resources. I'm just watching time. I don't want to run over time here. This is the TI Australia website. Let me just go back to the start of it. And if you're after resources, you can go into here and look up senior curriculum. Now, because I didn't want to spoil everything for you, I didn't go into the IB website. I've been just picking them out from the Australian curriculum ones. You can see most of it's very relevant. And I think it might have been under general maths or further. Let me just have a look. Local curriculum knowledge. There's some financial math stuff, geometry, measurement, data analysis. No, let's try general maths. We're looking for the one on the Fibonacci sequence. Arithmetic and number, no. Discrete mathematics. Here it is, look at that. There's that activity on the Fibonacci sequence, and here's the one on metallic numbers. So in the metallic numbers, if you've never used them before, let's say that the Fibonacci sequence is add up the previous two terms. In the silver ratio, we say, let's have 2 of the previous term and 1 of the one before that, and then add them up. And you repeat that. And for the bronze ratio, we have 3 of the previous term and 1 of the one before that. So instead of 1 of the previous and 1 of the one before that, we have multiple helpings of the previous term. And they're actually called the metallic ratios. So that's just another exploration that you can do. And I think that sort of thing fits in nicely with the IB program. But if you want activities specific to the IB, you can see there's a link down here. And activities like the ones you've been looking at today are all free. They're broken down by analysis and approaches, application and interpretation. There's some webinars you can watch for the IB program, both from Australia and the US. They've done webinars specific for IB. Let's have a look at the activities. It's laid out a little bit different, so you can use them for the 83 or 84 plus family or the Inspire. You only want to see the Inspire ones and just click up here. So you can see there's a wealth of activities and they're all free. You don't have to create them. Now, again, I'll send out an email of my PowerPoint rather, so that you can have links to all of the activities that we've done today. But do visit, I'll put a link to this part of the website in there as well. So do try and download some of those activities and explore. Anything you're doing on the computer software, like I've been doing today, works exactly the same on the calculator. Just going back a little bit, the other thing that we've set up on our Australian website, forgive me for promoting it, but that's what I work on here. We also have student resources. So there's teacher ones, there's STEM activities for those people that want to use the innovator and data logging. There's coding, if you want to get into coding. There's some really cool stuff you can do with coding, both graphically and mathematically. Amazing stuff if you want to push it down to the junior levels. You can use it in BASIC or Lua, and the latest one is Python. So you can use Python on the newer series. It's going to be released shortly. Under our student resources, we've also got a whole stack of things like tutorials to help kids get started. Once they get started, then there's tutorials by state and subject and device, and then you can look up, oh, I want to do something about calculating Z-scores. So let's just have a look at that one. There's a tutorial that tells students how to create a calculator Z-score, and then they can download the question sheet. So if they click on that one, it'll take them off to a quick video. Sadly, you'd have to listen to me again. I've muted it so you don't have to listen to me. So this one here says, okay, if you go back in time, you could have played this thing called Space Invaders, and people recorded their highest score, or it was recorded on the platform in which they were playing it. But those machines have long gone by, and they got replaced. Oops, let me just go back a bit, and I'll pause it. So there's this, the high score back in the days when they had those tabletop machines. But now they've got computers. People are able to get higher scores. So how can we compare those high scores to one another? Well, we look at them and they're normally distributed, and we can take the mean and standard deviation and get Z scores and use or compare Z scores. And it shows them how to do that on the calculator as well. And then they download the question sheet so they can get some help. And there's our question sheet. And if they need to go back to the video, they just scan that QR code and it'll take them straight back to the video. So you can see there's plenty of resources for teachers and students. I'm going to transfer across to Sanjeev. So let me just stop that for a moment. And change over. Are you there, Sanjeev?
Yeah, I am. Yep.
Hopefully I haven't put you to sleep. If you want to start, oh, nice, you're sharing the screen already.
Okay, so thank you very much, Peter. That was very informative, and I think one of the greatest things about the TI-nspire is the resources available on the website, both for teachers and for the students. And today I'm a TI trainer because I actually extensively use those resources, and I learned a lot from the website and what the other trainers shared. So I would highly recommend that if you want to start using the TI-nspire, if you start using the resources, that's for the teachers and for the students as well. All right, I'll take over now. What you are seeing is my calculator screen, and this is the TI-nspire CX2. This is the latest version. So prior to this, we just had the TI-nspire CX. So this is the non-CAS version that I'm using. And before I can start doing some exams style questions, I just want to show you I can actually change my display. So this is the teacher software. And at the moment, what you are seeing is what the student screen looks like. That's the calculator view. So I've got on my screen the keypad. So this is the keypad here, and this is the side screen. I can change the view. I can go to handheld only, which obviously for a presentation is not the best option. And I can go to handheld with the screen plus the side screen, but obviously I want people to see my keypad better, so that's the view I am using. And you can also see if I click on this plus or minus button, I can change the size. Because I'm doing a presentation, I want to maximize it, so that's the maximum screen that I am using. Now, at times when I'm in a classroom, when I'm using the projector, I actually swap my view to what is a computer view. And I'll just click that. And that's the computer view. The computer view, the text and everything looks much neater. But obviously, when I'm presenting to the students, I go back to the handheld view because I want them to see exactly everything as they would on their handheld. Okay. Now, one of the very powerful features of the TI-nspire is, as I mentioned, it's a very powerful teaching and learning tool. And there is an option when I go to File, you can see there is an option called New Publish View Document. Now, if I use the Publish View document, what it means is I can still use all the applications that are a part of the TI-nspire. But I can actually save it as a PDF. I can print it. I can do anything. I can use it and put it probably even on the student learning management system. So I put a few of these files on the LMS. And of course, if the students want to print this out, they can do that as well. So this is available on the student software as well. So if they want to write their notes, they can do that and print it out. So I'll just show you briefly what the Publish View offers. So this is the Publish View screen. And once again, you can obviously go and change the size. So I'll probably change it into what an A4 sheet of paper would look like. And what you see over here are the various objects that I can use, and these are the applications on top. So the first one I've got over here is insert a hyperlink. So I've inserted a hyperlink. If I just click that open, it should straight away take me to the reference guide for the TI-nspire. Now I've intentionally done that because if you want to start using the TI-nspire, this is a very helpful guide. It takes you through all the syntax, the steps, and everything. And if you just click, you'll find related activities as well. So if I want to print it, it's the same document that I have saved as a PDF, and this is what you will see. And then, of course, you can put it on the learning management system. So that's the same document that I've created in Publish View. You can insert, as you can see over here, images. So that's the image I have inserted. And I could actually go and put 3 points on this fountain and ask the students to write an equation for the quadratic. So we can model this fountain using quadratic. I won't be doing all that, but I'm just showing you that you can put any images. You can insert text. So that there is the text box. So all you need to do is just drag any of these. So I've just dragged the text box, and you can actually put any text over there. So that there is a text box. You can move it anywhere. You can resize it and do anything. So this is another advantage, on a calculator screen, it's very limited what you can see, but if you put it on the publish view, you can actually just lengthen the height of your display. Okay. Let's go to the next page. So this is a video clip that I've inserted. I can play the video here. And so that was a video file that I've inserted there. And then this is the actual calculator screen. And this is the calculator display. This over here is trying to do the same thing that I did on the calculator screen, but this is on a notes page. So you can see with the notes page, obviously we can add color. I can change the output color, the input color.
Just a moment, Sanjeev. I don't know if other participants are experiencing the same thing, because at the moment, my screen seems to be stuck on the PDF.
Oh, is it?
I'm just seeing the graphs, yeah.
Okay.
If any other participants can just send in their comments if they're seeing the same thing. It may be just me, but for mine, your screen hasn't refreshed.
Okay, let's do that again.
Yeah, we've got some other participants saying, yeah, they're experiencing the same thing, is it not seeing an update. So it now says viewing screen, it's coming through. No, it's dropped out.
I'll
I'm not sure whether
bring
yours
it up
has
again.
dropped out, your connection.
I think, yeah, there's a connection dropout, seems like.
Yeah, so it's still hearing you loud and clear through your headset. It says you're now starting to share. That's better. We're back.
Are we back now? Yeah. Okay.
Yeah.
So I'll just go. So we were able to watch the video. Did we watch the video at all? No.
No, I didn't see the video. I'm not sure when others dropped out. Maybe just show us the video section.
I'll do that again. Yeah. So if I go back here, so that was the text screen there, and this is the video.
And of course, Sanjeev is showing us a video of a mathematical calculation or some graphs and so on. But that can be a video of almost anything. It could be someone walking away from a street lamp and seeing the length of the shadow increase. Or it could be of a car travelling along, or a pendulum swing, which I was going to show you before, but I looked at the time and thought, no, I'll run out of time. So it can be any video. It could be a rocket being launched, anything.
Yeah, so it could be a non-mathematical video as well if you want to put there, but this
Where's
obviously
the fun
was,
in that? Come on.
yeah. uh, this was created using the TI-nspire graphing screen. Then this here is the actual calculator screen, so you can see the calculator output. And if I go further down, this is the notes page. And with the notes page, as I was mentioning, the advantage is you can change the input and output color, and you can change the size as well. So if I want to make that bigger, if I just click that, and you can see it gets bigger. So that's the advantage of the notes page. I can't do any of those on the calculator page. So I can hide the output or I can hide the input if I want to. And why would I hide the output? If I'm showing step-by-step working for some equations, I would probably hide the output and likewise input if I just want to only show the results. So probably at some stage I have done that when I'm doing the IB solutions. You can create widgets on the notes page. Of course, not on the notes page. You can there is a function and programming separate application. So you can actually write your own programs and have user-defined functions. Now this here is the geometry application, and just one application I've got, one display I've got over here. So this is the arc length. I'm changing the arc length, and you can see that the angle is changing. I can grab that and I can that, and you will see I've done a calculation on the geometry screen. So I'm saying what's the ratio of angle 1 to angle 2. So irrespective of what the arc length is, that ratio is always going to be 1 on 2, which is 0.5. And I can just move that. So it's pretty dynamic there.
And how long did it take you to draw that diagram as an estimate, Sanjeev?
Probably half a minute. So all I needed to do was
pretty
to put
quick, isn't it?
Yeah, but it's a matter of practice. So if as a beginner, I would say you just drop the circle there using the option, and then the center is already marked for you, and then you just put the arc, and that's it. Yeah.
Yeah, so participants would have seen when I drew the triangle before, well, it's exactly the same. You draw the circle, and then you've got the option to draw segments, measure angles, and it's ready to go, isn't it?
And then this here is the graphing application. And you'll see that I've got a square root function, which is 2x minus 7. That's the root function. And I can change the attributes and make it kind of stand out. So I've made it stand out. And then that there is the tangent. And the tangent actually was drawn using the geometry tools. I'm not going to display that over here because when I'm doing the IB solutions, I've got a similar question there. And you can see it puts up the equation for the tangent, and it giving me the coordinates for that point. And if I want, I can go and actually put the derivative there as well if I want to. So if I just click analyze, and if I say dy by dx, that's the derivative, and I click the point there, see it gives me the derivative of 0.758. Now that's obviously rounded off to 2 decimal places. If I went and changed the attributes, that will become 0.578 as well. So that's the part of the graphing screen. This is again something very helpful. I can create questions, and when I want to create questions, it gives me a wide choice. So let's go and actually do that. Insert question template, and you'll see it gives you a whole lot of options. So multiple choice, open response, equations, coordinates, that's points and lists, and you can have questions based on image. Of course, you won't worry about the chemistry part. So you can just create questions. So this is an open response question that I've got over here. We say state the gradient of the function. So we just got the gradient there, so I can be more precise. I can go and type in the gradient. And these can be sent to the students using the navigator. And the students can obviously respond. You can collect, and it will get marked automatically if you have specified the correct answers. Okay. Peter, do feel free to chip in if you have any comments to add. Okay.
Sorry, I was on mute. Yeah, well, so I was just typing something out to participants. I'll say it rather than typing it, it'd be quicker. Participants would have seen before I referenced the live view. So if you're using Navigator and you're thinking, here's a document, particularly in our current environment where there's potentially teaching kids online or remotely, if you like, the document that Sanjeev has got here gives us some idea on what you can create. And you don't even need screen capturing software. So if you're using Navigator, you can actually present your own calculator and record it. It'll save it as an MP4 file. So you can say, here's the instructions on how to do these steps, and here's the questions I want you to do. And because it's created that MP4 file, you can then embed it in this view that Sanjeev is presenting to you, and then just throw the questions, just type the questions in there. Or you can type them in as you'll see on Sanjeev's screen at the moment, there's a little light bulb with a tick in it. That's where you can insert a question. It's like a hidden application only available to teachers. And you can insert a question that requires an answer. So you can have a video in there, have some questions, and it's a complete learning platform that you can give to students. It's very cool.
Thank you. So what you're seeing now is the list and spreadsheet options. I've got two applications here. So that's the list and spreadsheet option. And then I've got the data and statistics screen over here. So that's the A value and that's the B value. And just, when I'm demonstrating what is an inverse, I swap the axis. So I put the B value on the X axis and the A value on the Y axis. Now, instead of a quadratic shape, they actually get a square root function shape. So that's a good demonstration as well. So that essentially is the publish view. And we talked about data logging or connecting to sensors. So that's the screen here, which is the vernier display. So at the moment, I don't have any sensors connected, but if I had any sensors connected, they will actually get activated straight away. All right, let's go to the IB exams.
So do you want me to show that? Just I know I was going to show it before, but since you mentioned it and I didn't show it, did you want me to show them what that looks like when you just connect and plug in?
Oh yeah, that's fine. Yeah.
Yeah. Let me just drag it back. So folks, we're just doing a quick transfer, and I'll demonstrate on the software. Let me just get rid of that one. You share. I'll just get rid of that file. I don't need it. I'll create a new document. I've got a calculator going. Now, sitting next to me, I've got this motion detector, the CBR as it's called, and I'll plug it into my computer. And on the student calculator, if the software doesn't launch straight away, because I had Navigator running in the background, let me just drop the DataQuest app in, and we'll plug the sensor in. Hopefully it's charged and ready to go. It's going to make a fool of me because it's not. The batteries are probably close to flat, are they? Let me just try plugging in. You can see it's trying. I must have something running in the background that it's picking up. It's not going to play ball for us today.
It does pick up straight away otherwise, yeah.
Yeah, but otherwise, yeah, I'd have it going. And I just clicked the little green button on here and hit start. Not sure why that didn't launch straight away. As I said, it must be that my batteries are almost flat. I'll give it one more shot of plugging in.
So I use it all the time with my students, and it straight away recognizes what the sensor is.
Yeah, I would hand it to Sanjeev, but he's in another building at the moment. He's at home. So I'll just send the thing back to you, and if I get that to, maybe I'll run away and charge some new batteries in it.
All right. So is my screen back?
Your screen again, sir.
Yeah. Okay. So for the IB examination, it says you are allowed a graphics display calculator. And although, the questions are worth 3, 4, or 5 marks, so that means you have to show some kind of working. But it does say that your answer doesn't have to be in the exact form. It can be up to 3 significant figures as well, especially if you're using the graphics display calculator. So let's look at the very first question. Now, these questions I've taken are from the May 2019 HL exam 2. So here it says, in a triangle ABC, the side AB is 5 units, BC is 14 units, and AC is 11 units. Find each of the 3 included angles and degrees to 1 decimal place. So it specifies 1 decimal place. Now you would see I've actually used the question template. So let's go and insert a calculator page. So if I want to insert a page, if I just do that, and here I've inserted a notes page. Now initially what I may do is I would use as if a student is using the calculator. Now every time I click on the calculator, you will see that the button will go red. So I want to do a calculation. Now to do a calculation, I need to insert a maths box. So that's Control M. Now, if I was using the calculator screen, I obviously don't need to do this because the calculator is available straight away. But because I'm using the notes page, it says I need to insert a control box. So what I'm going to do is insert the cosine rule. So from here, so that's cos, sorry, theta. So I can type it and go in quickly, and I'll pick up the symbols. So this tab is for symbols. This is the main catalog. So from here, I can go and pick up the symbol theta, and that should have gone inside the bracket. And then, of course, I'm going to write my rule out. So what I may do is I'll just doing that. So that's b square plus c square minus a square. So these are the sides, and that's 2 into side b into side c. So I just now this is obviously not very helpful because I need to give b, c, and a some values, and of course I need to do a solve as well. So the first thing I'm going to do is a numerical solve. So if I go into calculations here, and so you will see I get the n solve option. I'm going to just cut this and put it in the n solve option. Now I'm solving for theta. So let's go and do that. Now at the moment it won't give me any values. So I'm going to now put the condition line. It says when. Okay, so this vertical line is the condition line. I'm going to say a is equal to 14. Now those are the values that I had, and b equals 11 and c equals 5. Now when I'm on a notes page, I just need to do this once, and next time I can go and just change the variables there, and it gives me the answer in radians. Now if I want the answer in degrees, if I just go and click there, now that's new with the CX2, converts my answer into degrees straight away. So I don't have to make any conversion. So that's back in radians, that's in degrees. Now I'll just show you
something else. Sorry, Sanjeev. Can I ask? Or you're probably about to show it too, are you? Putting a sign. Oh, it's up round wrong.
Yeah.
If they put a degree sign on the angle, what does that do?
Oh, then they don't have to worry.
Yeah. If you try it now and see if that changes well. You can try the round thing first.
Yep.
No, in the cosine theta.
Oh no, I was just going to do that as well. Yeah. Yep. So that's where go and put the degree symbol.
Yep.
Yep. And I'll change that to radians. Yep. And let's click enter.
And press enter.
Yeah. So now
it overrides it, which is pretty cool.
Yeah. So now you will see I also put the round syntax because the question said rounded off to 1 decimal place. So if I just change that to 2 decimal places, it gives me 117.04. So that's finding each of the sides. Now to find the other sides, all I need to do is just change this to a square plus c square and b squared. So if I just change that to b, and that I change to a, and then that changes to a as well. And that should give me the other angles. So once I've created this in a notes page, I can just do it for all the 3 sides. So that was question number 1. Okay, I'll probably come back to this one later on because I've in a way covered this. But if I wanted to just, okay. I'll do that since we are here. If I wanted to see what is the best linear regression I could obtain over here, so using certain transformations, if I just go and do a correlation, at the moment the current correlation is this. So I've used the correlation matrix. Now I'll show you where did I get that from. But if I do square of that, and it actually gives me a very good value of R, and probably it's the best. So I can just try any combinations here just for comparison. Let's do y square, and obviously that's not going to be good. So it's telling me that's the best value of R I potentially have. So where do I find the correlation metric? So if I go into menu, calculations, and statistics, and then stat calculations, which is number 1. And right at the bottom, now I can't see it, but I know it's the letter G. So if I go and click the letter G, you'll see it brings up the correlation matrix for me. And all I need to do is put the X list and then the Y list. So that's my X list and that's my Y list. And I could try any of those. And obviously this is telling me that possibly is the best transformation to linearize the data. And if I want to check that, let's see. Go to menu and once again start calculations. That's number 6. And let's go to start calculations, which is number 1. And we will do one variable statistics. Or let's do a linear regression because we want to see what's the equation. So for the X list, I'm actually going to do X val. So that's the X value. And if I square it over here, because I wanted to square it, and that's my Y value, and it will save my function as F2. I can actually call it anything. And let's go and click OK. And it gives me the value of R as 0.099. So it's a very high correlation. And that's the value of R squared. Now, if I want to go to a particular value from here, let's say I want the residual values. So if I just click over here, the variable key, you can see it's got all the variables. And if I want to go to the residual values, if I just click that, it shows me all the residual values. Now, it's showing far too many decimal places. If you want to see 2 decimal places, all you need to go in front and just put the round syntax that I did earlier. Round to 2 decimal places. And you can see it's given me the residual values to 2 decimal places. All right, moving on to the next question. I'm trying to rush through everything because of the time factor. So here we have a question on complex numbers where it says z square equals this. Express your answer in the polar form and then in the Cartesian form. Now let's do that on the CAS. Now, interestingly, I'll actually just copy that bit there. And if I go here, M, so I'm pasting this. And you'll see actually it simplifies to 4i. So that straight away simplifies to this. Now, if I'm finding the solutions, or sorry, expressing it in the Cartesian form. So let's do the positive one first. And if I just type that there, I'm just using the copy paste, and the calculator does allow you to do that. That's giving me the answer in the Cartesian form. So that's obviously root 2 plus root 2i. And if I go and put the negative sign outside, that gives me the equation. So those are the 2, but I can I'll demonstrate using another option just now. Now I want to go and convert this to polar. So to convert to a polar, if I go into menu, calculations, and under number, you'll see complex number tools. And then you will see you've got convert to polar. Okay. Now, oh, I should have put that in front. So let's do that. So when I convert to polar, it gives me one of the solutions. And if I go and change that to plus, it should give me the other one. So I've got in the polar form as well.
What happens if you change that to degrees? Does that still work for you, Sanjeev?
Okay.
Just try clicking up on the degree sign up the top.
Yeah. Actually, that's a better
That's
view,
nice,
probably. Yeah. So that's giving us the R value and then the angle. So that's probably better. Yeah. But I'm guessing because they have to express the answer in radians. Yeah, that should be fine.
Yeah,
but
just thinking
yeah,
if they
so
wanted
that's
the
telling
exact
them
value,
that's
they have to put some pi
yeah.
on
So
4.
yeah, so that tells them it's pi on 4. So that's so the other way is if I go into calculations and I go into algebra, and you'll see I have polynomial tools, and back again, so calculations and algebra, and then number 3 is polynomial tools, and then you see complex roots of a polynomial. And now if I just grab this, and I can't have equal to sign, so minus, because we are kind of equating it to 0, and if I do comma z, but of course it's not an equation, so it's an expression. That's something we need to be careful with when we are doing polynomial roots. If I do that, domain error, what happened there? Z square minus 4e. That's interesting. It should work. I'm not sure what's causing the problem. Yeah.
Just check, is your document in real mode or complex mode?
Okay. So if I just go to
Overriding
setting,
polynomial C roots.
No, that should not make any difference. Okay. Yeah, but it does work, because if I just drag it here, let's see. No, I'm not sure what's causing that. It's definitely work.
Yeah.
Yeah.
Okay. Look, you go on to the next question. I'll have a little look on my computer and see if I can figure out what your fault is.
Okay.
Yeah.
Okay. This is a very similar question, so I guess I'll skip this one. But I can actually probably just show you. Okay, I'll try this one. Let's see. So insert notes page. Yeah, see, it works here. So I'm not sure why it didn't work there. So I've used the same. So that's the question there. W cubed equals 8i. So now I've used polynomial roots for W and it has worked. So I'm wondering why that one didn't work. So maybe there was something incorrectly I entered. Okay, in this one here, the marks obtained by students in a test are given over here. Find the mean and the standard deviation. Then the teacher decided to increase the mark by 2 for each of the students. Find the new mean and the standard deviation. So I'm just going to copy that because I need that. And let's go here, insert a new notes page. Now you will see I'm going to actually store this as my first list. So these are the original marks for the students. I'll call this as M1. and then the teacher decided to increase the marks by 2 for each one. So if I do M1 plus 2, that should give me the new list, and I'm going to store that as M2. So you'll see it's added 2 to each of the marks. So I've got the marks there. Now, the easiest way is to go and do a stat calculation. So statistics and stat calculation. And because I've got two lists, I can go actually do two variables. And in the X list, I'm going to put M1, and in the other list, I'm going to put M2. And it gives me the mean. So let's go and look at the first one. The mean is 6.75. And if I go to the right, it should give me the other one. That's sorry, I need to go down. Yeah, because it's got both the variables together. So we are looking for the.
So what you said on the screen, the Y mean was 8.75. I think I saw it just further up.
So if I go, yeah, that's the Y mean there. Yep. And likewise, when I'm looking for the standard deviation, this is the standard deviation that we are looking for. And the standard deviation for Y and the standard deviation for X obviously should be the same. And that's what it is. Now, a quick way to do this would be by inserting a data and statistics page. Sorry, let's insert it from here. Sorry, that's what not my intention was. Data and statistics.
Control Z and undo.
Yeah. So data and statistics page, and if I go and put M1 there, and then if I click menu and analyze, and sorry, plot properties, plot type, normal probability. Yeah. So if I do that, you can see that's the mean there, and that there is the standard deviation. Now, if I go and change this to M2 here, you'll see my mean changes to 8.75, but the standard deviation remains the same. So that's another way to work this out. Okay, let's go to the next question. The function is defined. So we have a function secant x plus 2 in the domain of 0 to pi by 2. State the range and find the inverse of the function. So the best thing is to go and actually graph it. So I have that doesn't look right again.
Change to radians.
Yeah, that's what. Yeah. So that's the actual graph there. Now I may just go and adjust the scale there. So I can go into menu and change the Windows setting from there. But looking at it, probably I know what are the values I want. So that's 2. So let's go and change that to probably about 3. And the other trick would be if I go back there, if I want to change each one of these, if I just click tab, it will take me to the next one. And I'll just change that to -1. Tab, I don't want anything really there. So I'll change that to -1 as well. And tab. And now I have a better view of the graph. So we are stating the domain. The domain is pretty obvious if I look at it. So that's 3 and above. So the sorry, the range. So the range for me is 3 and greater than 3. So all real numbers greater than equal to 3. So y can take values greater than equal to 3. However, if I just go and add a notes page, which I'll do over here itself, and if I do the function value at 0 and control M, so it tells me that the minimum value there, so function value at 0 is 3, and then obviously the range goes up to infinity. So I can work out the range from there. And then what was the other part of the question? Find the inverse and also state its domain. So we do know that the range of the original function will become the domain of the inverse. And because we are hard pressed for time.
Can you show them, Sanjeev, how you write the inverse? Just go back to your page 6.2.
This one here?
Yeah. If you go back to page 6.2.
Yeah.
And you swap back over to your graph.
Okay. So as a relation, yeah.
As a relation, yeah. X equals f of y, or f1 of y in this case, yeah.
Yeah.
So that's a really powerful
so
thing.
Control 6. So if I go and do Control G, now instead of inserting a function, if I click there and I go into the relation option, so if I go x equals secant y plus 2.
Why not just put f?
Type anything or secant
y. You could have typed in
f1 of y
f1
as
of y,
well. Yeah.
That's kind of nice. You can show them you just swap x and y.
I did try that. Let's say control.
You didn't like it?
No, there was an error that I got, a variable not defined or something. But I'll give it a try again. So Control G. So if I change that to
in relational graphing.
Oh, sorry, yeah, relation.
And type in x equals f1 of y. You want?
Yeah.
You've got a minus sign.
So it does that, and then of course I need to go and control the domain because my range was that. So if I go and change that to 8 or something, so you can see the inverse graph over there. But obviously we need to restrict the domain so as to make it 1 to 1. So we can work out the range from there, and
well, that's the beauty of the one that you've got, the x equals f1 of y. It's automatically done it over the restricted domain because it had the restricted domain for your other one.
Yeah. So the other thing that probably the student should have done instead of doing secant x, if they had done 1 over cos, that may have helped as well to find the inverse straight away.
Yep. Yeah.
Okay. So there are a few other questions. So that's what I had originally. Yep. So that's the inverse there. And so that's going to be the inverse there with the domain x greater than 3. So what I may do is, because we are out of time, I do have all the solutions for the 2019 May examination. Now that was on solids of revolution. So these are the two functions. And this is rotated to form a vase. It's rotated by 360 degrees. And the two equations are given. So that's the graph we have done on the CAS. You would, I want you to notice something. I don't know if you have tried this, Peter, but I can actually even put the other condition. So over here, we are saying x squared plus 1 such that x is greater than equal to 0. And my function has to lie between 0 and 9. So less than equal to 9. I've tried that, putting the function value there. It worked really well. This is the first time I tried it, and it worked well.
That's cool.
Yeah. So that's the formula for finding the volume when it is rotated about the y-axis. So that was my first equation. Now obviously I need to rewrite this in terms of y. So when I change it, so that x squared is y minus 1. So I've gone and substituted there in the first volume, and then in the second one, for me, root y is this. So going and substituting there. So I've gone and substituted, and I've done these together. So that's doing the two together. So the outer curve minus the inner curve, and that gives me the volume as 168.05. So sorry, I'm rushing through it, not giving much of an explanation because of the time factor. So I think it's already nearly 6. So I'll stop there. But there are the other questions, solving the inequality. So the solutions are there. And then likewise determine the point with the tangent to the function, such as the x-axis. So the point is given, and that's the function. So that can be done graphically. And this is a question on normal and binomial distribution. So the solutions will all be provided. So I'll email the solutions to Revati, and then she can pass them on to everyone else. But it's already 6 now. So there are about yeah, a few more questions there. Yeah. So it's quite self-explanatory if you actually start playing with the file, because you'll get the TNS file, and you'll find it's pretty self-explanatory there. All right, I'll hand over to Peter, and then who will probably hand over to Revati.
Thank you, Sanjeev. I just thought, well, while you were talking about solids of revolution, I didn't cover 3D graphing, so I thought might as well show that one while I'm at it, that you can do some nice examples of rotating around the x-axis or rotating around the y-axis and animate those things. Obviously, you can then change your view of it to see what it looks like, to get a decent perspective on it. The other thing which I did do, I found out that I did have other software running in the background. I'll plug that motion sensor in now. You can see there it is plugged in. Software already started. You saw it was pretty much instantaneous. And then if I click the play button, I've just got a pendulum sitting in front of that motion detector.
Oh, wow, that's a nice curve.
And yeah, and someone had asked in the chat, what sort of maths can you do with it with the data collection? Well, there's a nice example. We can model a trig function over the top of it. It's collected velocity and acceleration at the same time. So you can do beyond the trig, you can go into calculus.
Can you bring up the acceleration one, and it will give the value of g actually?
Yes. Well, yes, you can. You can work out g from that as well.
Yeah, but actually,
the objective's pretty good.
Yeah.
Yep. Now let me just get Revati on the line. Are you there?
Yes. Thank you, Sanjay and Mr. Peter, for the informative session. I'm Revati from Statistics and Numerical Analytics Group. On behalf of StatWorks and Numerical Analytics Instruments, I would like to thank all the teachers for joining us today for the webinar in spite of your hectic schedule. We have recorded the show and we'll share the link with you all. You can share with your colleagues who have missed to join today. And any inquiries or questions about the pricing of the GDC or any other service related questions, please contact us. Myself, Revati, and my colleague, Mr. Akhilesh, will help you out. Thank you so much.